All right. All right, all right. All right. First video of this channel, my goal is to just show everybody a repair, and I'll explain to you what we're doing later on in a bit. But the goal is to just show what processes we go through and I go through, find the problems and see what we gotta do to fix them. And I thought maybe I'll upload this video, somebody will watch it. Maybe. It's worth a try, right? Alright. Alright, so we got here in front of me, this is a body control module from a 2000, let me check. It's a 2013 Fiat 500. And the problem that this Fiat was having is that the headlights would not turn off. Both of the headlights, the low beams. Everything else turns off, tail light turns off, interior lights turn off, but almost like something is sticking and the tail light is not, the headlight is not turning off. So went through it and checked the relays, checked everything. Now on these Fiats, as well as pretty much any majority of the newer cars, they don't use really a 12 volt switch circuit that's just gonna be controlling the headlight, that will connect directly to the headlight switch, the one you twist that's next to the steering wheel, usually the one you twist to turn on the light. Usually on the newer cars, it doesn't go directly to the headlight. What the newer cars are doing is that when you turn on the headlight switch inside the car, the signal is sent through the CAN bus network. So the headlight switch is turned on. The switch itself has a microprocessor that sends the signal to the body control module, and the body control module says, okay, we got the signal to turn on the headlights. And then internally in here, it will flip a relay or a transistor, whatever, to turn on the headlight. Now, the issue we're having with this Fiat, obviously, as I said, it's the low beam headlight is not turning off, and it just ends up draining the battery overnight. And this is for the car of one of my customers. He has a dealership, he fixes a lot of his cars, and just want to go through the process, show you what I did and what I have to fix to get this car back on the road. So let me get this covers off. We're not gonna need these plastic covers. What I did do when the part was on the car, I tested for the grounds and power at the headlight. No issues over there, so this is not a ground issue. I tested power and ground at the body control module. That looks good. I looked at the live data and the scanner to see if the switch itself is commanding the headlights to come on and off, and it is. Everything is working normal. Body control sees that. But for some reason, when turning off the headlight switch, we still got the 12 volt output out of this board through one of these pins that goes to turn on the headlight. Even with the switch off, it's still sending power. So now I know this is either a wiring issue or an issue with the board. I did remove the wiring to test, for example, possibly maybe the wiring itself was shorted to a 12 volt positive. So I disconnected from body control module, took this out of equation, tested the car again, and the headlights turned off and not turning on again. So I know the wiring is intact from the body control module to the headlight itself. Wiring is intact. So I know my problem is in this. Now, if we look at this body control module, this is what usually Fiat does. Obviously, the headlights of the car and the tail lights, these are high amperage circuits, right? So they draw a lot of amperage. You cannot just send, 10 amps through this to the board itself, right, or to the switch itself. Remember, everything works on a CAN bus system in these cars. But instead of having an external relay, like on a 2000s Toyota that would actually turn on the headlights and you could remove it and replace it, these have an internal relay on this body control module. As you can see, we got some relays here. We have some here. We have two black ones here, two white ones here. These are some of the fuses that will control the headlight circuit. Let me get a pointing device. These two fuses control the left headlight low beam and the right headlight low beam. And on the back, we got some other IC chips, resistors, which I'm not really concerned about that right now because the body control module seems to be working fine. Now, how do I know the problem is in this, right? You might be asking, well, I removed the cover while I had it on the car, turned off the headlight switch. The headlights were staying on, obviously. Now, one trick you can do on these mini relays to test them to make sure if they're stuck on, because relays can stick on, and even though you're not sending a power to them to, turn them on, let's say the microprocessor is saying turn off. But the relay can stick and stay on. So remove this cover, tested it. Now what I did, one trick you can do on the relay, you can go and tap them on them. Tap on this. Did it make any noise? Did the headlights turn off? No. Tap on this. Headlights are still on. Headlight is still on. Tap on this. Oh, the headlight turned off. See what I mean? So this is what happened when I was testing it on the car. I removed the plastic cover. I'm tapping on the relays to make sure, and testing on these, headlight turns off. So now I know I'm dealing with a sticking relay inside of this box itself. That's the quick way of testing it, because it's not like an external relay where you could remove this and measure the resistance of the coil inside. You can't really do that. These are soldered onto this board. So what I'm trying to do for this customer, and usually I don't do this, I don't repair circuit boards, mainly because most of the customers, they cannot wait for me to order the parts, and most of the time it comes from China. It takes time, and I put it on, and if something goes wrong, whatever, it's gonna take time to do this kind of repairs. My customers need their car fast. So usually in a situation like this, we would end up replacing this whole module and reprogramming it. But for this customer, this is a dealership. They don't mind their car being out of commission for a week or a couple weeks. And, I kind of like it too. It's like puzzle. It's food for the brain. Go through and figure out what's going on and see if we can fix it. So I know these two relays control the low beam headlights, and that's the circuit we have a problem with. I know that relay is sticking. Okay. Why do relays stick? Relays can stick by either, if you're sending too much current through them, that's one way they can stick, where the contact point of the relay will actually weld together. Or it could be bad design, or it could be just, defective part. A relay is a wear item. It does wear out. It's anytime any piece of metal is moving, it will eventually wear out. The same thing can happen on your household air conditioning units. They have, I forgot what they call them, but it kind of looks like a relay. It's a main switch. If you turn off your AC from the thermostat and it doesn't turn off, it keeps going off, it is possible one of the issues, or the issue you could be having, would be that relay sticking. Now on these I cannot remove the relay to look inside, but I could do some basic tests once I remove this board. Now I was able to source these relays on I think I found them on Amazon actually. I was able to source these. I will get it out of the plastic in a second. Let me do that real quick actually. All right, got these relays opened up. Now the number on these two is VS Vector 23086 Charlie 1021 Alpha 502. If I compared with this, Victor 23086 Charlie 1021 A 502. So should be able to work with this. And you can see this is a simple, 4-pin relay circuit. The two bigger pins over here, they are in charge of passing the actual high amperage load, which in this case would be the headlights. And the two smaller ones, this is the control circuit. So you apply 12 volt on one point, you apply a ground signal on that point, it will close a solenoid in here, which will activate this circuit. It will close this switch. That's basically how most relays work, without getting into transistors, which kind of look like these with 3 pins, 4 pins. Basically, that's what they were. Now, what do I need to service this? This is what Fiat loves to do. I've seen plenty of this design, plenty of times. In order to save space, they will take the two circuit boards and join them together. See these pins over here? They will join them. So it's kind of like sandwiched together, right? There's one on that side and the other is on this side. Okay. Now, in the case of Fiat, based on my experience, I've noticed that these, and some cars it could be this way too, but some of these pins are not there just to hold these two boards together. Obviously, that's one purpose. But some of these pins are actually grounding points for other components. So I'm not sure if you can see that. PCB trace goes all the way back into where the fuses are. That's a power. So either way, they share circuits. Some electricity, for the lack of a better word, is flowing through these. Now to get to these relays, the pins are right under there, right there. So what I need to do, I need to separate these two boards, take that off, and take that off. Now, how do we do that? How do we do that? Because if you see these pins, they're not soldered on. It's almost like a quick fitting push clip. See, Chrysler does the same, Jeep does the same, and Fiat does this too. Now, what's the benefit of this? Well, for the factory that makes these, it allows them for a quicker assembly, where they don't have to have a machine come and solder each individual pin. They make it in these clip styles where they put the two boards together, push, click. All right, good connection. Sometimes these do come loose, especially on the steering wheel's position sensor on Jeep Wranglers. I've noticed these come loose, bad connection. So that's the downside compared to, having actual pins soldered. So I do need to remove this. How do I remove this? as you can see, we get a good focus. It kind of looks like an A shape, right? There's like a A, and then this one again, A. So I need to twist, no, not twist, what's a better word? I need to push these two legs together on all of these. Or I could cut them, but I don't recommend doing that. First thing I'm gonna try is pushing all of these together. And I only need to do it on one side, because once one side of this board, for example, if this comes off, right, I can just access the other side of the board. So I don't need to go through both sides and crimp these down. However, I do have two, one here and one here. So I've noticed best tool for these is something like this, wire cutters, preferably small ones. I cannot find the small one. I'm gonna try to use this. I will probably start unclipping on this side, because why? Path of least resistance. I have more space here all around these. I'm gonna start to do that. So let's see, I'll do a couple on the camera and I'll have you skip through when I have all of them off, so that way you're not sitting here watching paint dry. So I'm gonna pretty much put my pliers on there and give it a little push. All right. Okay, maybe you can see the difference now. Can you focus? Focus, focus. So this one, I just pushed it in a little bit. The legs are crimped together. This one is the one I haven't touched. I don't know if you're able to see it on camera or not. You can kind of see. So I'm going to go through, do this and this, so I can actually separate these boards to work on the relay. And then we're also going to have processes of how to desolder and remove the relay. And if I have patience and time, maybe I can show you the circuit board. Because remember that the factories do not provide you a wiring diagram on these circuits. You're pretty much trying to back engineer, reverse engineer it, right? That's pretty much what you're trying to do. Okay, I tapped on that relay. That one turned off the headlights, so I know those two control the headlight circuit. All right, let me go through these pins. I'll bring you right back. All right, that was a pain in the ass. So I did go ahead and finally remove this. Now what I ended up having to do, and I don't know what Fiat is using on these, and Chrysler's is usually easier to pull out. But what I ended up doing was I had to actually grind down all the tabs and pry it from here. These things are compression fit. This is really, really in there. Okay, so guys, if you're trying to do this yourself, you have to be really careful. You will probably mess up the board. You could bend the board, which I did a little bit. I was able to bend it back. You could pull out the board, or worst case, you can crack the board, which if you crack it, then it's just a paperweight, you know. So a lot of swearing, a lot of pulling, tugging. Eventually, I was able to get it out. Now, I got one pin right here. I got one pin that unfortunately got stuck in here. I was trying to test out a solder point on it, and it got stuck in there. So I would need to put this back in there. Now, this is going to be okay. I think the board is going to be salvageable. It did damage the plastics a little bit over here, but that's not a big problem. These are molded around these pins, so these pins are not moving. These are still solid pins, if you can see them. Yeah. All right, so I know probably for some people it may not be worth it, but we got a little bit of damage over there. But these pins, thankfully, are not carrying any important circuits. They're just either 12 volt pins or grounding pins. So when we put it back together, it's not going to be any issue. I will have these connections repaired. The board appears to be straight and no crack. So we will put solder points on these and put it back together. So this is the one side of the board where we have some transistors, resistors. It looks like a central CPU that pretty much runs the body control module, some other IC chips. We're not worrying about this because this is not the issue. Let me put this aside. The issue is on this side. Now, this looks more like I guess you could call it an analog board or like a 1980s board. You know, the pins are big, the solder points are huge, accessible, not too many tiny, SMD components, surface mount components. So these are the two relays. How do we go about changing these? So when we look at it in the back, we got 1, 2, 3, 4. That's 4 of the pins of one relay. And we got one sitting right under this plastic connector. 1, 2, 3, 4. Ideally, we could remove this connector. However, look what kind of connection we have. We have the same press fit connection on that. We're not going to take that connector out. That's going to be a pain. We can bend it, we can break it. So I have to work around here. This relay will probably be a little easier to get out. This one will probably be a little harder. What I'm going to try to do, I'm going to use a desoldering wick. I have it here. Use a desoldering wick. That's going to be my first step. I'm going to put it on, try to get as much solder out as possible. If I was able to move it and pull out the relays, great. If not, then we're going to move into what are we going to do? Actually, I would probably try the hot air station. Now with this, we have to be careful. There is a chance that this hot air station can melt this plastic down here. But if you look at the spacing of the pins inside of this connector, it has a pretty big difference, space between here and the pins. Now this is a really, really thick board as well, a lot of copper. Using a hot air station on this is going to take a long time to heat up all those solder points. So ideally, I really want to use a soldering iron, desoldering wick, and see if we can take these relays out. So let me turn on the soldering iron. I'm gonna just go with 600 Fahrenheit for now. I'm gonna take this glove off. All right. First one puts a little bit of flux. Probably not needed, but I like to use it anyways. Hope you're able to see that. A little bit of flux. I'm gonna start with the easier relay. This one where I have a little bit more space. And I'm gonna attempt to desolder it. So I'm gonna use the desoldering wick. I'm gonna cut it off a little bit. Just a tad. All right. Let's attack this easy pin. Now this is the big pin that carries the actual current. With desoldering wicks, you want to ideally put the desoldering wick on top of the solder point. Give it time to melt, and the idea behind this is that that solder that's on this board is going to get transferred into this wick. Now this way I probably will get most of the solder out, but it is possible that doesn't get all of the solder out, and we may not be able to pull out that relay, which if that's the case, then I will move into a hot air station. With a hot air station, I can warm up a lot of the area, all around the area. Looks like my solder is still warming up. Also, the hot air station makes it easier for surface mounted components. I remember I was doing a repair on a Mini Cooper, the cylinder number 3 misfire. There was injector was good, ignition coil, coil pack, everything good, but using the oscilloscope I saw that it is not actually grounding out the coil to make it spark. Remove the computer on those on that Mini Cooper, which everything is glued on. That takes a long time too. And removed that transistor it had that would actually turn on the ignition coil for that cylinder. You can test transistors actually with soldering, with multimeters. Maybe in the future I will do another video on how to test those transistors. Let me adjust the temperature of the soldering iron a little bit. I'll be right back. All right, so I tried adjusting the temperature on the soldering iron, but this is really, really thick board, and it's taking a long time just to heat up connections. It's just the normal iron, right? So what I'm going to do, I'm going to use my hot air station. I've got this set up at about 800 Fahrenheit. And I know that may be a little high, but this is a really thick board. I really need it to warm up. So I already preheated the board a little bit and tried it on that connection right there. And that one seems to work. I'm gonna try this other connection right here. Let me cut a little piece of this wick again. That's better. All right, let's hit it. I hope you guys can see this, but I'm getting close to the solder joint, keeping the heat on it, the hot air station. As soon as I see the solder melt, I will put the wick on it. Again, this is a really, really thick board. It's copper, you know, copper is a good conductor of electricity. I'll put that wick right next to it. And any moment now we should start to melt. Let's increase the temperature. I may need to preheat the board again. Sometimes you can also add a little bit of solder if that solder doesn't seem to be melting off. Just add a little solder to that joint. Okay. And look. A little bit more flux. Now I'm going to come back with the iron. And you may not be able to see this connection, but okay, so I got majority of the solder removed. What I'm going to do, because you kind of see how it's poking out a little bit. What I'm going to do, I'm going to use a Hutter station to heat it up while I try to hold on to the relay to pull it out. So I'm trying to heat it up in the bottom to melt the remaining of the solder. Ideally, I would have a board secured to some place I can just pull on it, but working with what I got, you know. No, I'm sorry for blocking the view. I can start feeling it loosening up. Just waiting on one pin. Last pin. There we go. That is one relay out. These sticker boards are really a pain to desolder everything. They don't want to heat up. They don't want to get separated. But if there's a wheel, there's a way. I'm just gonna remove the remainder of the solder down here so I can actually have a clean hole. Now this one, Still, there's some solder left in that hole. I cannot seem to get it out. What I'm gonna do, I'm gonna add a little more solder. Once I add the solder onto that, yeah, this board is cooling down way too fast. Once it is melted again, I'm gonna use the wick to get out that solder. Because the hole needs to be open. If it's clogged up with solder, I cannot get the new relay put back in. I've definitely noticed a lot of car electronics, really thick boards. Sometimes up to a point where doing repairs on them is almost doesn't make sense. Still got some solder stuck in there. Gonna see if I can go from the other side of the board. Twig that solder up. It's those two tiny pins that are the control side of the circuit. I've definitely noticed in the recent years, probably after 2010, manufacturers are making electronic repairs almost impossible. Either being from hard to remove parts, glue in positions where the glue is not needed, crimped connections where crimped connections is not needed. It has definitely impacted the auto industry, probably more than anything else. This is where the importance of right to repair comes in, right? We should all have the right to repair our stuff. Just that simple. It is just that simple. Now these two holes are still clogged. Trying to punch through them. That way, sorry, you can't see that. There you go. So I unclog that. Now we go after this one. Hopes to have a steady hand, I don't. Yes, I know I'm not using the right tool for the job. I barely use the right tool for the job. Let's try that on the back. for a little more solder. See, this board really cools down fast, even though I have my solder on the highest setting. Let me get this hole cleaned up. I'll be right back. All right, I got that hole cleaned up to the best of my ability. Now, I did the amount of heat I have to put in. I did end up melting this little piece of plastic tab. That's not functional part of it. It's gonna be okay. So now comes the hard one. Let's see if I can just move this away. Primitive tools. Because this is on my way of getting to that solder point. And this is what I mean by manufacturers making it harder to do repairs. But still won't stop me. Still gonna get this board fixed. So we got one relay out. We need to get the other relay. I'm gonna use the same technique. I'm gonna heat up the board. This will probably melt a little bit of the plastic, but in this case I really don't have much more choice besides buying a new board. So I'm heating up this area right now using both the hot air station and the soldering iron. Heating these up, and I wonder if I can get all four pins all four solder points melted at the same time, where I could actually just pull out the relay. Of course, what I'm afraid of here is melting that plastic connection. So I'm gonna go back to the soldering wick. Now that I've heated up the board, should be a little bit easier to melt these. Let's see. I believe I got one. The bigger pins are easier to desolder. It's always the smaller pins that give you issues, because the solder likes to stick in the hole because of the surface tension. Getting the big pin right now. This board is starting to cool down already. So I'm going to leave the wick and the soldering iron on there. Get the air station back on here. Heat up that joint area. Wow. Okay. I believe got 3 of them. Now this is the part where I need to go back, keep a hodder station on there while I simultaneously try to pull out that relay. And hold on to that relay from the back. Try to heat it up and wiggle it. I really need to get a mount. Okay. Oh my god. What the fuck is this? Alright. So now, trying to heat it up with the air station, and then I'm going to push on the pins to make that relay drop down. Again, trying to be careful to not either overheat the board or melt more plastics. And we got it. There goes that relay. Got 2 relays out. Now the rest would be just cleaning up the holes a little bit. I would like to solder this back on while the board is still hot, because I'm having a lot of issues with how thick this board is and how much it's taking to just warm up to a point where I can actually take out the solder. So we got a little bit of cleanup on this hole. I'm going to try to go through it from this side as well. It will be this hole over here. Little flux. Good thing about having a board this thick is chances of you burning the board slim to none. That heat gets dissipated so fast. I need the hodder station and the soldering iron. with the wick. To get it in that hole, suck out the solder, and we got a clean hole. While we're here, while the board is still warm, got our 2 bad relays here. So I'm gonna move these aside. Get 2 of our good relays. And we should be able to pop these back in. Looks like this goes on like this way. And I will probably start with one, do the other next. Now to keep this from falling down, put something under here to hold that relay. We can clearly see the pins coming out over there. I'll probably hold it on my hand, get a little solder. My soldering iron. And just tap on one of the legs. As long as one of the legs are on, it will hold. That's one. Let's get the other leg soldered up. See, now that the board is hot, easy to solder. Even though this board cools down really fast. See, I got a problem with the solder joint back here. I may need to use the air station again. Heat up that board. And this soldering iron is hot. This is on right now 800 Fahrenheit. At least that's what the controller says. But this is just super thick board. You always want to make sure your solder points are completely melted. You want to have a good soldered point. Boom. Let's move to the other leg. Let me change this tip real quick. Got a new tip. This one's a little thicker. It's a better choice for heat dissipation. Turn down the air station. A little more flux. I love flux because it makes that heat dissipation a lot easier. That's really the main key. You want heat to disperse into the pins. And get stuck on there. All right. Board is cooling down. Heat it up. I just want to go back through all the connections, make sure they're all melted good and nice and evenly. Making good connection with the board, that's crucial. All right, Time for the second relay. This is a good one. Let's see, line up the pins. Goes in this way. Now on the other side of this, one of the holes didn't get cleaned up too well. So I do need to heat that up so I can push this in. Now the soldering iron. Touch that pin. I'm gonna put a little solder on these and then just heat them up and push them through. Drop the relay. Nice. Let's see. Put up the solder points. It's probably the wrong way to do it. But at least I'm trying, right? I don't think that will work. Let's clean up these solders. Give it another try. There you go. Let's try that again. The holes are cleared. Boom, like butter. Put a little solder. Turn the board back. Get enough just on one of these pins, just enough to hold it. Okay, that's holding. Let's go back to soldering. A little bit of flux. Heat it up. Good connection. Connection. See, this board is sucking out the heat too fast. We need that air gun again, or air gun, the hot air station. Heat it up. Boom. Last pin. Boom. You really want to see the solder flow through. That way you know you have a great connection. Inspecting the points. Everything looks good besides looking messy. Give them a wiggle test just to make sure they're not moving, the solder points are not moving, and that is fixed, at least in theory. Just looking at the solder points again. Everything looks good. I'll probably put a little more solder on that one of the legs back there. Does look like it ain't got enough. Boom. Bada beam, bada boom. How does that look? Let me get some alcohol, I'll clean it up and look back at that. Got the alcohol, let's see. Let's clean that up again. Yeah, I'm supposed to use cotton pads. I know, I'm supposed to be doing a lot of things. But again, with limited access to tools, this is the best I can do right now. There will be a little bit of black spot left on here. That's from the plastic of this connector getting burnt up. It's just the leg. There's no functionality issues. I know it is melted in there. But you got to think about it. When they manufacture this in a factory, they don't have this on here when they're soldering this. The plastic connector is off. All these are off. They dip this down into a solution of molten solder. So all the connectors on there, they're not going to fall off. Dip this down, bring it back up, solder will dry or will get hard. They flip it over, and these are those push pins, right? These are clipped on, they're not soldered on. And then they will take it, boom, 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 put the connector on, assemble, send it through, right? So the fact that I'm trying to do a repair on it, in fact, is made to be almost impossible to repair these boards. But with enough patience and some practice, you could repair these. There's some brown spots left over. I'm not too worried about that. That's flux. The flux I use is non-corrosive. It may not look pretty, but it is functional. Now, I should have this tested on the car tomorrow. I'll make a video of that. And then we'll go from there. This relay is not seated in all the way. I guess you could kind of see it. That's because I was trying to hold it off again. I don't have a stand for the board. I'm trying to work with what I got. But functionally, all these pins are absolutely covered with solder. This should be functional. Now we got to get the other board back on here, get it soldered on. So let me get the other board. This board is still a little warm. This one is cold. We may need to heat this up, these connection points, to put this back on. I do know I have a pin sticking here. So what I will do, I will try to line this up and be extra gentle with it. Touching on this side. Once you get to these pins, push them a little bit. See? They pop back through. Now, because I had to shave down these pins, I would do need to solder these back on. So let's push that. I ideally want to get them to the flush point where they were before. If not, I may need to heat it up a lot just to make sure that all of these pins get soldered on them. I'll put a little pressure, being extra careful. This side looks good, this side needs a little more. That's better. This side needs a little more. That's better. Again, when you push these, you need to support the back. Just push it like that, you're gonna break the board. That should be functional. And really the most important pin on this is this 3 back here. To go to this transistor. So let's heat this up. We'll start with this side. Put some flux and then get it soldered on. Get that hotter station warmed up again. And heat this up. I'm gonna do one side first and then the other side later. Now when you do soldering, especially if you use flux, gotta make sure you're in a well ventilated area. This stuff makes a lot of smoke. Am I in a well ventilated area? No. But I got a window open. That should be good enough, right? Alright, that's a little warmed up. Get the soldering iron, some wire. Let's attack this. I'm pretty much going pin by pin, dropping a little solder on them. Keep the board hot. You let this cool down, soldering iron is going to stick, your wire is going to stick, the solder is not going to flow through. See, feel the board cooling down. I'm gonna get my hotter station back on there. Be careful with these smaller components, these are surface mounted. If you heat these up too much, you will literally blow them off because this thing's blowing hot air. You will blow those off. And then good luck finding it. That's warmed up. Let's continue. More solder. Keep in mind my soldering iron is on the hottest setting and this board is still sucking in that heat like there's no tomorrow. Alright, we got solder on all of them. Now to make sure I got good penetration, I do my soldering iron and the hotter station. Hotter station will heat up the board, soldering iron will give it localized heat. I will run it over these. Those are good. Those are good. Those are good. That's good penetration. I'm going to clean up the soldering iron. Let's take a look. Got good penetration. I can literally see the solder flowing out on this side. That's good. Now that one pin that came out with this board, I will solder it on the back side as well. So let's do that. It was this foremost pin. Little flux on it. Hotter station, heat it up. With the soldering iron. Then I'll give it a little solder. Just like that. Now this way I know that if when that pin came out, something broke in there, or this pin is not sitting all the way, which it is not. But at least I know it has connection. Ugly, yes. Functional, you bet. And I will probably be the last person that will see this circuit board until this car ends up in a junkyard, pretty much, after its life is ended. Gonna heat up this other side as well. Over here I gotta be really careful. These resistors over here are, I think they're capacitors. These will blow away easy. That's heated. Now we move on to our soldering iron. Melt and put it on here. Go pin by pin. Don't worry if it looks like it's not penetrating yet. We're gonna go back over it with the putter station and the soldering iron. All right, let's go back with both. Now these pins, if they touch, it will not be a big deal, but still I would like to keep them from touching each other. Like when the solder melts, sometimes solder between two pins can stick together. And that is it. You have good penetration. Let's see, pin number 4 on this side, pin number 4 on that side, yep. See, some of these pins have no functionality. These lower pins, if you see the light green area compared to the dark green area, the light green area is where the copper traces are. And you literally see them connected to each other, kind of like wires. These top pins have function because they go to this chip. It's probably the supply power to the chip. Now, these bottom pins, they go nowhere. Let's see if you can see it. These bottom pins, they go nowhere. The top pins, they're feeding this chip. They're also going into here and into here. So I think some of the components share their power between the board using these pins. Pretty much I believe that to be true. All right, cleanup time. Isopropyl alcohol. Clean up that flux. There we go, ladies and gentlemen. That's one board put back together. Got our fuses, relays, these two were replaced. And it's getting ready to be tested on the car. I will try to put it on the car tomorrow, take a video of it. And hopefully the results are what we expect. Hopefully the results are not something that's unexpected. So I will say bye for now, and then the scene is gonna cut into the car tomorrow. Got that body control module connected back in its place. Now I'm gonna turn on the ignition and test the headlight switch. Working good. That is it. That's the repaired body control module.